Hello everyone. Good morning to everyone. Uh, in the previous session, we discussed up to the theoretical parts of the complete segregation model, and today in this session, I am going to discuss about the mean conversion in the CSTR and mean conversion in the PFR separately. Okay, so in the previous lecture, actually, I have discussed about I have taken single example of the first order reaction and how we convert the how we calculate the conversion. So let's try to understand how will we solving the problem with this particular question concept. Okay. Yeah. So, yeah, when we talk about mean conversion in PF CSTR, so here I'm writing mean conversion in CSTR. Okay. So when we talk about mean residence time distribution plot ET, that is equals to 1 upon tau m and e to the power minus t upon tau m, that you all know these things. Okay, it's as simple as that. Residence time distribution curve for continuous state intact. And I'm taking about for first order reaction. Okay, for first order reaction, what we can use xt is equals to 1 minus e to the power minus kt. Okay, everything will be comfortable for this. Xt is e to the power 1 minus kt. Now, when we talk about average conversion from segregation model, that is used to be equals to xt into et. Are you getting? So can I write here it is equals to 0 to t. Here it is equals to 1 minus e to the power minus kt, and et is 1 upon tau m e to the power minus t upon tau m. Are you getting? From here, and it is dt. So can I convert it? That is equals to 1 upon tau m, that will come out of the integration, and 0 to t. Here you will can write 1 minus e to the power minus kt and e to the power minus of t by tau m and dt. Are you getting? So from here we can write x bar, that is equals to, my dear friend, 1 upon tau m, and you can convert integral e to the power minus t by tau m dt and 0 to t. Are you getting? Minus e to the power minus t k plus 1 upon tau m, and again integral, and it is equals to dt, and here 0 to k. So are you getting? So from here you can calculate x bar, that is equal to 1 upon tau m minus of tau m and e to the power minus t by tau m plus e to the power minus t k plus 1 upon tau m, okay, upon k plus 1 upon tau m. It's a simple, the integration that you all know these things. I have to calculate, and that is equal to my result finally 1 upon tau m. Okay, and this is equal to plus tau m plus 1 upon k plus 1 upon tau m. Okay, so can I write here 1 upon tau m and k tau m plus 1, and sorry, here it will be equals to minus 1, no? Here it is minus 1. Once you do substitute the value, so here it is plus 1 and here it is minus 1 upon k plus 1 by time. So this and this will get cancelled out. Just wait 1 second. Yeah. So finally, you will be getting from here uh, x bar that is equal to k tau m upon 1 plus k tau m, and tau m that you will be given that is equal to v by v naught, mean residence time. Okay, from here. So yeah, this is the way that you can solve from the conversion for first order reaction inside the CSTR. Okay, but everything that is rate constant time will be given, and according to that you can calculate. Okay, so now I am going to calculate conversion from ideal PFR. It's also very important thing how we calculate conversion from ideal PFR. So there is some mathematical thing that you need to understand whenever we solve the problem from ideal PFR. So my dear student, the mean residence time distribution curve for ideal PFR that you all know, that is a direct delta function del t minus of tau p. You all know these things, and it's very important that you should know it is equals to del t minus tau p. Okay. Now we know for first order reaction I'm going xt is equals to 1 minus e to the power minus of kt. For first order reaction. Okay, so can I calculate my result mean conversion x that is equals to xt into et dt, and it will be 0 to t. Are you getting? Yeah, sorry, just wait 1 second, let me change the slide. So, I mean, you need to understand the at least the mean RTD curve for RTD function for PFR CSTR that you should know earlier, and after that you can understand the thing. So here I have written for first order reaction, my dear student, x is equals to mean conversion that is equals to xt and ET. Okay. So now moving next. So when we talk about direct delta function, del t equals to 0 when, just like understand one thing, if we are talking about 0 to t del t minus tau p, and here it is ft tt, and that is equals to, my dear student, ft if tau p is 0 is less than tau p is less than t, and that is equals to 0 if tau p does not lie in between 0 to t. Okay, if it does not lie between 0 to 2, then it will be equals to 0. So again here we are going to calculate 0 to t del t minus tau p, and function is 1 minus e to the power minus kt. Okay, dt. So that will be equals to 1 minus e to the power minus k tau p. Sorry, here if it will be tau p, it will be e to the power 1 minus e to the power minus k tau p. Are you getting? So mean conversion from here there, that is equals to 1 minus e to the power minus of k tau p. 1 minus e to the power minus of k tau p for the first order reaction. So my dear students, you can understand from here. So for first order reaction, it is as simple. If you calculate from normal, normally for the first order reaction, again you will be getting the value of x bar is equals to 1 minus e to the power minus k tau p. So first order reaction signify that conversion of the fluid element that does not depends upon the initial concentration of the reactant. First thing. Second thing is, it also does not depends upon the neighboring fluid. That's why the normal conversion getting that you will get from the plug flow reactor, that will be equals to 1 minus e minus k tau p. And again from the segregation model you are also getting the conversion, average conversion, that is equals to 1 minus e minus of k tau p. So both of these are same. So this signifies that first order reaction does not depends upon the conversion from the first order reaction in the PFR, does not depend upon the that neighboring fluid or RTD function. Okay, or initial or sorry, only depends upon the RTD function, and it does not depends upon the initial and final initial concentration of the reactant as well as the mixing. Okay, so yeah, this is the way that you can understand the segregation model. And in the next lecture, I will be discussing the maximum mixedness model and tank in series model, and from there we'll let you know how we'll solve the problem from there. Okay, so thank you for watching this video.